Okay, so in this video we're going to have a look at two exam questions involving inverse trig functions. So again, we're going to translate our question. We've been asked to differentiate. Here's my function. And they tell us with respect to x, that's fine. X is my only variable in the question. So we don't need to highlight that part. The minute I see my inverse function, I'm going to my log tables, page 25, and there's my formula for cos inverse. So all we need to do is match up our relevant terms that we're going to sub into that formula. So that's the format they gave it in the question, and our format in the log tables is written like that. And that'll give us 1 over root of a squared minus x squared. So from this, x over a, my x value stays as is, and my a value is equal to 4. So I'm going to sub in. So I get dy dx is equal to minus 1 all over the root of my a value we said is 4, so it'll be 4 squared minus my x value, which is x. The root of that we can tidy up, so it'll be minus 1 over 4 squared will give me 16, x squared gives me back 16, and that's us done. So just at the end we can write our answer in a bit neater. We get minus 1 all over the root of 16 minus x squared, and that's that question done. 5 marks. Pretty straightforward, 5 marks. So now what we're going to do is we're going to come over and have a look at this second question. So we've been asked to differentiate. We see here we have cos inverse. So again, I see that I'm thinking about this formula in my log tables, and again with respect to x. Now because our formats here don't match up, it tells me I'm dealing with a composite function, so I'm going to have to go and use chain rule. First thing I'm going to do with this function, cos inverse of 4 over x, I'm going to rewrite it as cos inverse of 4 over x all over 1. My reason for that is it now fits my format of x over a. And then I'm also going to have to use chain rule. Okay, so for my chain rule, I'm going to deal with my outside function first. And then our inside function, which is my 4 over x. Differentiate my outside function. Here's where we're subbing into our formula. So just maybe a little bit of setup work. My x value is equal to 4 over x. My a value is equal to 1. So it'll be equal to sub into our formula minus 1 over the root of a squared, which is 1 squared minus 4 over x to be squared, and we get our root. Minus 1 all over the root of 1, and then a little bit of tidying up here. I'm going to get 1 minus 16 over x squared, and we put that under the root. So that's u part differentiated. Now we'll have a look at v, so I'm going to go and rewrite that. Bring up my x and it comes to the power minus 1. So now for differentiating, bring down your minus 1, we'll get minus 4x to the power minus 2. I'm going to rewrite that, just make it a bit easier. I'll get minus 4 all over x squared, bring my x to the power minus 2 down. Okay, so now our chain rule tells us that we multiply du dx by dv dx. So it'll be minus 1 all over the root of 1 minus 16 over x squared multiplied by minus 4 over x squared. So first thing for me, you have a minus by minus is going to give me a plus. So on top we get 4 all over x squared root 1 minus 16 over x squared. That's fine. My next thing is to find my LCD. So that'll be x squared over 1 minus 16 all over x squared. We can apply the root to the top and the bottom. We apply, we get x squared minus 16. Just applying our LCD for this part in the middle. So all that happens there is we get 1 by x squared minus 16 times 1 all over x squared. It's going to tidy up to x squared minus 16 all over x squared. So that's how I've gone from that step there to my next step. And then just it's all underneath the root. So this line here will give me x squared minus 16 over, and I apply my root here. Just tidying up as much as I can. Apply our root and we get x. So what's going to happen then is our x squared here will cancel and my x will cancel. At the end I get 4 over x root x squared minus 16. And that's us done. So a very, very awkward question in terms of the manipulation. The differentiation was relatively straightforward once we isolated our outside and inside function. And to do that we need to recognise that it wasn't in the format for the log tables. So a little bit of work to do there, apply your chain rule, and then at the end these last 2 lines were just manipulation. So that's that question answered, and that is 10 marks. And that's us done for both examples for inverse trig functions.